The region formed by y equals 2x, y equals 0, and x equals 1 is revolved around the line x equals 2. Find the volume using washers and shells. Now that we have both methods, let's see how they work here. So we're going to sketch this line. We have y equals 2x, so a little steeper. We have y equals 0. Y equals 0 would be the x-axis, and x equals 1. So we have something like this. So we have this triangular region, and then we have a dotted line at 2. We're going to start on this side, and we're going to revolve it around there. And now we're going to copy the region. Now note, I don't need to copy all the extra stuff. So I'll just draw a triangle over here. And I'm going to use washers. For washers, I would need a horizontal rectangle here. And so I'll label this as delta y. We're going to copy that over into our other region, and then basically connect the front and the back. And you can see the washer shape there. Now remember, this is a point on this curve, and all points can be described as x comma y, and similarly we can say the same thing about that point. In order to find this volume, we're going to need to find the area of this disc or washer that has a hole in it. And so we need the inner radius, and we'll need the outer radius. And that will come to there. Well, the inner radius is the difference between two lines, and it's a horizontal line segment, so it's going to be the right minus the left. So that inner radius will be 2 minus 1, or 1. The outer radius is going to be 2 minus, again, a horizontal line. We're subtracting the x values on a horizontal line. So the right x value, it'll be x on the right side minus x on the left side. The right x value is 2. The left x value, we could say at first, is just x, but what is that? Are we allowed to leave it in terms of x? No, because as soon as we label this as delta y, we know that this integral is going to have to be in terms of y. So what is x equal? Well, we have here that y equals 2 over x, so x is y over 2. So this outer radius will be 2 minus y over 2. We take the area now, and the area will be 2 minus y over 2 quantity squared, because this is the radius squared. And we're going to multiply this by pi. Let's put parentheses here. Minus the inner radius squared, which is just 1. When we take that area and multiply by the thickness, we'll get the volume of a slice. We let the thickness go to 0 and sum them all up, or I should say sum them all up, let it go to 0, and we get our integral. Now, what are the limits of this? Again, it's delta y, so that means we're going to be dealing with y numbers. The smallest y number is going to be starting at y equals 0, and it's going to go all the way up to here. Now, we haven't calculated that value. This is x equals 1, so we could just look at it and say, okay, that's y equals 2, since it's 2 times 1. So we're going from 0 to 2. And the rest of this is just algebra. So we're going to go 0 to 2, multiply that out. Combine your like terms. Let's move this up a little bit. And I'll just rearrange it. Y squared over 4 minus 2y plus 3. Now the only thing we've done so far is just multiply and simplify. We actually haven't integrated. So now we're going to integrate, and we'll have y cubed over 12 minus y squared plus 3y, and we need to evaluate that from 0 to 2, and always remember our pi added on. So plug in 2, so that'd be 8 over 12, or 2/3, minus 4 plus 6, and then plug in 0, make sure you've checked that. In this case, It's not a problem. It's just 0. Here we get 2 plus 2/3, which is 8/3. So it's going to be 8 pi over 3. And we're talking about volume, so it's unit cubed. Now let's do the same problem with shells. When we're going to do shells, let's first just quickly copy it down, our region, sketch our line. We're going to be revolving around that again. You don't want to spend a whole lot of time on that. Now we're going to draw a vertical rectangle. This will be labeled delta x. We're going to copy it over into our other region. And then connect these ones. You could either make that back part dotted or solid. It really doesn't matter. But let's try to at least connect the corners there. Of the top rectangle goes to the top of this rectangle. The bottom of the rectangle goes to the bottom of this one. We're going to cut open that shell, and we get an approximation for a rectangular prism. We're labeling this delta x. This is going to be, this circle opened up will become 2 pi times the radius, and we need to calculate what the radius is. The radius is the distance from the axis of rotation, or axis of revolution, to our element. Again, this is a horizontal line segment, right? We're going along the x-axis. The right side is 2, and the left side is x. Recall that this is a point x comma y. Now, again, let's look at our thickness here. This is delta x. This is telling us that it has to be everything in terms of x. So when we have 2 minus x, that's good. We're done with that. We don't want to do anything more. And then the height of this shell will be the top minus the bottom. Well, this is y equals 2x, and this is y equals 0, so it's just 2x. Now we can set up our integral, and we're going to go 2 pi. We can take that out. 2 minus x times 2x dx. Now, what are the limits now for our integral? We're going to slide our rectangle throughout our region. The lowest value is 0. And what's the upper value? Well, that line is 1. So we're going from 0 to 1. Remember, everything in this integral has to be in terms of x because this is delta x, just as everything in the first one was in terms of y, since that thickness was delta y. Now we go through the algebra steps. Multiply this stuff out, 4x minus 2x squared. Find the antiderivative, 2x squared minus 2/3 x cubed. Evaluate from 0 to 1. So we get 2 pi times 2 minus 2/3, which would be 2 pi times 4/3. And we get 8 pi over 3 units cubed. So we get the exact same thing. In this particular problem, it did not matter which method we use. In fact, we are told we had to use both. And you can see the differences on how to approach them. And that's it.